Alright, so the next question says the equation of H, which is the axis of symmetry of G, which has a positive gradient. So here's the thing about axis of symmetry where a hyperbola is concerned. What we know is that the axis of symmetry, there are two axes of symmetries for a hyperbola. There is a positive gradient axis of symmetry, and that positive gradient axis of symmetry, it actually passes through the point of intersection of the vertical asymptote and the horizontal asymptote. So obviously that would be 0 and 1. That would be the coordinates of the point of intersection of the vertical asymptote and the horizontal asymptote. That is where the positive gradient axis of symmetry passes through. Then there is a negative gradient axis of symmetry that passes through that very same point of intersection of the vertical asymptote and the horizontal asymptote. The coordinates are 0 and 1. Now what's beautiful is that the gradient of the positive axis of symmetry is always equal to 1. And then the gradient of the negative axis of symmetry is always equal to -1. Whether in grade 10, grade 11, or grade 12, that is always the case. So what we then have is the form y is equal to negative, right? Now we say x plus p plus q, with the gradient being negative, so we write -1, okay? If it is the negative gradient, we write +1 if it is the positive gradient axis of symmetry. And guys, all we simply do is that if we go to the denominator of the function, remember this is x, and in grade 11 obviously we could say x plus 0, we could say x minus 0, doesn't really matter. So what we do is we simply harvest this denominator and we harvest the q value, and we go and substitute it in the form of this basic equation, which is a straight line. So we basically come here, y is equal to 1, since we want the positive axis of symmetry. We write x plus 0, and then the q value, remember the q value was +1 for the hyperbola function. And all we do is we distribute the 1. So that will be y is equal to x, 1 times x is x, 1 times 0 is 0, and then obviously we remove that bracket and then we add the +1. And the equation is y is equal to x. 0 plus 1 is 1. So this is the equation of the axis of symmetry. Remember they said the equation of h, so therefore we are going to then have to say y is equal to h of x, x plus 1. And there it is, done and dusted. Okay, then what they said is that they said sketch the graph of h on the provided diagram sheet. Clearly show all asymptotes and intercepts with the axes. Okay, so now we need to sketch the graph of h on that particular provided diagram. So there we have it. Okay, so now what's important here is that because in the diagram we didn't have our asymptote, so what we're going to do is we are going to now sketch the function y is equal to x plus 1. Remember h of x, we've just found that the axis of symmetry for the function that has a positive gradient is h of x is equal to x plus 1. So we are going to sketch that on. Remember we need the y-intercept and the x-intercept for this particular axis of symmetry. But remember, we know that the function passes through here. Okay, and then let's find the x-intercept. So let's let y be equal to 0 for this positive axis of symmetry. So that would mean in the place of h of x, which is y, we substitute 0, and then we solve for x. We transpose the 1, becomes -1. So therefore x is equal to -1. That means our x-intercept is -1 and 0. So that's where the function is passing through here, right? Okay, and then we can just roughly go ahead, use our ruler. Okay, and that's h of x. And there it is. Okay, there it is. Okay, yeah, so we've shown the intercepts with the axes, which is beautiful. Okay, now the next question says write the equations of the asymptotes of f if f of x is equal to negative g of x plus 3. Okay, so let's go to write the equations of the asymptotes of f. So f is the new function because we did not have f initially. So f of x is equal to negative g of x plus 3. So in other words, what are they saying? This is g of x, and we need to actually say f of x is equal to, remember, the negative sign means there's a reflection. Okay, so let's say 4 over x plus 1, okay, because that's negative of all of that, plus what? Plus 3. Okay, yeah, plus 3. Okay, so we need to negative of all of that, g of x is this 4 over x plus 1, and then we need to add 3. So let's just do this. Let's take this negative sign and distribute it into the function. So we have negative 4 over x minus 1. That removes the brackets, and then we add the 3. So finally our answer is negative 4 over x minus 1 plus 3. Guys, what's negative 1 plus 3? That gives us positive 2. So this is the function of f of x. And what did they want? They wanted us to write the equations of the asymptotes. So first and foremost, let's look at the horizontal asymptote. The horizontal asymptote will be equal to y is equal to 2. Because remember, this 2 value, alright, gives us the horizontal asymptote. Then lastly, our vertical asymptote. We see that the x is still isolated in the denominator, so therefore that means what value of x can, for this fraction, what can x not be? X cannot be 0. So that means x is equal to 0 is the vertical asymptote. Okay, so hopefully that makes sense, and we are able to see when they ask us this question, right, the equations. Remember, they want the equation of both the horizontal and the vertical asymptote, if they say the equations, and of the asymptotes of f. F is a new function. Remember, initially in the question itself, there was no function of f. So f is a new function. Okay, but how is this function formed? It is formed by negative g of x. In other words, right, that means we're changing y, okay, for f of x, for g of x, which means it's a reflection in the x-axis. Okay, and therefore we negative of g of x, the function g of x, we were able to find it's 4 over x plus 1. So that means we say negative of that function g of x, and then obviously it says plus 3, so we need to add 3. So we distribute the negative sign, because remember, with odd mass we start with brackets, and then obviously multiplication, then addition later. So that's why we distribute the negative into the bracket. We get negative 4 over x minus 1 plus 3. We then add the like terms. We get negative 4 over x plus 2, and then from that we are able to state what the horizontal asymptote is, the q value as it is, so y is equal to 2, and then the vertical asymptote, since x is isolated, we take that variable, equate it to 0, and that is the vertical asymptote. If it was a binomial term in the numerator, we take the binomial term, equate it to 0, and solve for x, and that would be our vertical asymptote. Okay.